The sun. That bright, warm ball in the sky that gives us light, heat, life. And one day, death. It's the reason we exist, and also the reason we won't exist forever. The idea that our own star will destroy us might sound dramatic, even poetic. But this isn't science fiction. This is science. Our sun has a life cycle, and that cycle includes a very real expiration date. And when that day comes, Earth won't just be uncomfortable. It'll be uninhabitable. Then unrecognizable. Then, gone. So what exactly happens? When does the danger begin? And can we do anything about it? Let's follow the timeline from today's calm sunshine, all the way to cosmic extinction. Right now, we're living in what scientists call the main sequence phase of the sun's life, basically, its golden years. This phase began about 4.6 billion years ago, and it's expected to last another 5 billion years. During this time, the sun fuses hydrogen into helium in its core, releasing immense amounts of energy. We're talking 386 billion megawatts per second, that's more energy than humanity has used in all of history. Every single second. And here's the catch, the sun is slowly getting brighter and hotter. Since Earth formed, the sun has increased its luminosity by around 30%, and this trend will continue. Even though this seems slow on a human scale, for the Earth's climate, it's a ticking time bomb. In about 500 million years, the sun's increasing brightness will start to disrupt the delicate balance of life on Earth. Plant life, which forms the foundation of the food chain, relies on photosynthesis, which is sensitive to temperature. As temperatures rise, many plants will struggle to survive. Carbon dioxide levels will drop. And without enough CO2, photosynthesis will slow, then stop. The oxygen in our atmosphere? It'll start to vanish. Even long before the oceans boil, the decline in photosynthesis could mean the end of complex life, animals, insects, humans. Earth becomes a planet of simple, heat-resistant microbes, if anything at all. This is the beginning of the end, and it arrives far sooner than most people imagine. Fast forward to 1 billion years from now, the sun is around 10% brighter, and things get worse. A lot worse. This is when Earth is expected to enter a runaway greenhouse effect, similar to what happened on Venus. The oceans will begin to evaporate, releasing more water vapor into the atmosphere. And since water vapor is a potent greenhouse gas, it traps more heat, causing even more evaporation. This positive feedback loop spirals out of control. Eventually, the oceans boil away. Rain stops. Rivers dry up. Clouds disappear. The planet's average surface temperature could exceed 100 degrees Celsius, 212 degrees Fahrenheit. Life as we know it is gone. Permanently. Even microbial life, the hardiest organisms known to science, would have nowhere to hide. With the oceans gone and the surface scorched, Earth's tectonic activity slows. Volcanoes quiet down. The carbon cycle collapses. Plate movement ceases. The Earth is becoming geologically dead. Meanwhile, the atmosphere begins to erode. The ozone layer is long gone. And without protection from solar and cosmic radiation, Earth is bombarded by high-energy particles. The magnetic field, generated by Earth's molten iron core, may begin to weaken or shut down, leaving the planet defenseless. By this point, the Earth resembles Mars more than the lush, blue world we know today. Dry, cracked surface. No water. No air. No life. A tomb orbiting a star that's only getting worse. Around 5 billion years from now, the sun will run out of hydrogen in its core. That's the moment everything changes. With no hydrogen left to fuse, the core collapses under gravity, while the outer layers expand outward. The sun becomes a red giant, a bloated, unstable, seething mass of plasma. Its radius increases by over 100 times. It could swallow Mercury, Venus, and perhaps even Earth. But will it? That depends on complex gravitational dynamics. As the sun loses mass, Earth's orbit expands slightly. But not much. We may avoid direct engulfment, but the heat and radiation from the red giant will vaporize our planet's surface. We're talking over 2000 degrees Celsius on the surface. Mountains melt. The crust peels away. What's left is a scorched iron nickel core, possibly still orbiting, but utterly destroyed. The red giant phase doesn't last forever. It's unstable and violent. Eventually, the sun will shed its outer layers, creating a glowing shell of gas known as a planetary nebula. This nebula can stretch across light years, shining in blues, reds, and purples for thousands of years. They're some of the most beautiful objects in the universe, and they're the death shrouds of stars. At the center remains a white dwarf, a dense, Earth-sized remnant of the Sun. It no longer fuses elements. It simply glows faintly, cooling over trillions of years. Earth, if it still exists, is now a charred pebble, adrift in an expanding bubble of gas. But, do we have to go down with a ship? The good news is, we've got time. Over 1 billion years before the real trouble starts. That's plenty of time, assuming civilization survives, to do something about it. One idea? Move Earth. Seriously, scientists have proposed using gravitational slingshots with asteroids to gradually shift Earth's orbit outward, keeping it in the habitable zone. It would take thousands of years and unimaginable coordination, but it's technically possible. Other options? Colonizing Mars, or building space habitats, like O'Neill cylinders, that float in space, powered by solar energy. More ambitious still, finding a new star system to call home. The technology doesn't exist yet, but neither did powered flight 150 years ago. Given time and vision, humanity might survive its parent star's death. The elements that make up your body, carbon, calcium, iron, were forged in the hearts of ancient stars. And one day, our sun will help seed the galaxy with its own dust and gas. Maybe it'll help form new stars. New planets. Maybe even new life. So in a way, the death of the sun is just a step in the cosmic cycle. We are stardust. And when the sun dies, it'll give back what it once gave us. From that perspective, Earth's destruction isn't a tragedy. It's part of something far bigger. The sun gave us everything: light, warmth, life. And in time, it will take it all away. But we are not powerless. We are the first species, that we know of, to understand our star's life and death. To predict the future. To plan for it. We may not stop the sun from dying, but maybe, just maybe, we can write ourselves into the next chapter. And that story is still ours to tell.